Now we look at the impact of different types of data analytics on human input. All right. Based on this diagram, we know that for descriptive data analytics that answer question what happened, it will require relatively more human input compared to diagnostic, analytics, predictive, and prescriptive. What do I mean by human input? Human input means that further data analysis, all right, further action that a human need to do before applying the results from this data analytics. All right, from this data analysis. For example, run a descriptive data analytics telling us what. It's only informing us what had happened, so what. In order to do something, we will do further data analysis. For example, after doing descriptive analytics, we will do more steps, for example, followed by diagnostic analytics. And then from diagnostic analytics, maybe we will also do the third analytics, which is which is predictive. Then only we will look at what will be the action to be taken. All right, right now that would be similar to prescriptive analytics, right? In short, based on what I say just now, we should have some understanding that to reach our analytics to the lowest level here, which is prescriptive, which already in some way, all right, or actually you can say most of the time, before we come to, or when we say we are doing the prescriptive data analytics, actually, before we reach this stage, we have already done descriptive analytics, diagnostic, and or predictive analytics before we come to this, the last stage of analytics, which is called prescriptive. In short, in our working life, when we say that we have implemented a prescriptive data analytics, it means that we have already done some sort of, all right, if not all, of the above 3 data analytics. All right. So here we can see that when we have done some prescriptive data analytics, we can use the result to support top manager or top management in decision making. When we have already done this prescriptive data analytics, depends on type of decision, all right, that decision can also be automated, all right, and this lead to the actual action, all right. Yeah. And actually this slide is from the previous slide here. And in short, this diagram is actually somehow based on this diagram, all right, this source, right, this source data journey. And here, what I have already added on top of the previous slides here. Previous slides here is the application area, okay, and the nature of this analytics. Either is hindsight telling us what we've done in the past, insight, or actually it is about our foresight. And the one in green color, okay, implying that requiring human input, this will be correspond to various type of additional data analytics. All right, for example, misbehavior. After we have done descriptive. We want to know, okay, we want to know why, okay, such thing happened in the past. We will come to diagnostic, right? Okay, when you do diagnostic, we will first of all do some, okay, pattern capturing. What happened? Okay, do we have some data about some transaction pattern? Some data, some data about, for example, about previous transaction pattern. And then if it's about product, maybe we will do some product status checking or benchmark analysis and so on. Okay, and anyway, for this, the one in green color is actually describing, okay, under this each type of data analytics, what kind of additional human inputs we will do. And usually this kind of human inputs, it will also require the subsequent, okay, a more stronger type of data analytics that will correspond to the type of data analytics underneath it, right? Okay. So for diagnostic analytics, actually, what we do here for human input, we will do fault diagnosis. All right, you will further do, for example, maybe root cause analysis. Okay, that one based on the fishbone diagram, right? Yeah. For example, if we have a network breakdown, we will have to understand why the network breakdown. We will ask, okay, at least 5 whys, why such thing happen and so on. All right. Yeah, of course, we can ask maybe within 3 to 5 why and why. Okay, the more why we ask correspond to a problem. Okay, the more detail, okay, cause of the problem can be understood. And also for diagnostic analytics, we also do some anomaly detection. All right, we want to understand why some problem happened. Okay, and that unexpected event will cause that anomaly to happen. So we have to detect where, when, okay, and how it happened, right? And then for predictive data analytics, is meant for foresight. All right, that means, yeah, giving us a prediction what will happen in the future, right? What will happen? Something will happen. What will happen in the future? This is foresight. And here sometimes we will use this predictive analytics in order, for example, to analyze our consumer behavior. Okay, customer coming from this segment, okay, this area, buying this product, will this customer be a profitable customer in the future? Okay, will this customer will do future repurchasing? Okay, will this customer come back? All right, will this customer have high loyalty? That will be consumer behavior prediction. Okay, you can predict various types of things. All right, repurchasing decision for that customer, customer loyalty. All right, and then customer churn rate, will it leave? Okay, will it have a high retention? Okay, and then we can also use the predictive analytics in order machine maintenance predictions, right? But usually this kind of prediction analytics is based on what happened in the past, in order to build a prediction model, to build a regression model, right? And then after that, maybe we will do further. We can make some decision, all right? Or actually from here we may, from the what we predict, maybe we will go to, we will do more analytics. For example, try to analyze what can we do from what, based on what we predict, right? Here, for example, we may do some AHP. Okay, AHP is analytics hierarchical process. All right, whereby we try to analyze. It will involve several layers of factors to be considered and the impact of each factor. Okay, on the decision. This is a bit complicated. All right, and then for decision prescriptive analytics, it can also lead to either it may lead to direct decision support or for decision making, or we may automate the decisions computed by this prescriptive model in order to make system automation or machine automation. All right, this kind of prescriptive analytics, it can be used in order to monitor our system, for example, our system reliability, system optimization, system resilience, right? And then here here we are going to look at where different types of data analytics being applied. You know that descriptive analytics is about hindsight, telling us what had happened, right? For example, we may do benchmark analysis. Benchmark analysis here is an example. For example, we are company A, all right? And we want to compare how does our company perform relative to our industry, relative to the leader in our industry, leader B, right? And want to do our benchmark analysis. And take an example. Our benchmark score is based on, for example, customer satisfaction, okay, operating margin, yeah, and then on-time delivery. Okay, assume that our benchmark analysis is based on these three factors or three index. And then based on these three, we come up with a overall benchmark score. And here we are doing so-called benchmark analysis because we are comparing who we are with the average performer in our industries, right? Industry average. And we are comparing us also with the leader, the top performer in our industry. Okay, this is called this is our descriptive analytics. Is telling us where we are in the market, right? Actually, I mean, based on this benchmark analysis result, this telling us, okay, what our performance is, right? Okay, our performance in the industry. Yeah, it is obvious that this company A is underperforming. All right. Okay, compared to the average competitors in the same industry. And not to say it, okay, not to mention our performance compared to the leader, right? And then for diagnostic example from diagnostic analysis, it would be, trying to do the anomaly. Here, this diagram is to show us the anomaly detection. It can be coming from anything. Okay, it could be machine temperature, or it could be our equipment performance. Okay, so detection and alerting. Normal for the for example, for normal, under normal operations, the graph that we observe will be what? Green color straight line, right? Under normal operations. And then anomaly will be detected when some unexpected, okay, things happen. Okay, then our graph, okay, our monitoring graph will show something weird like this. All right, and giving us some alerts. All right, why? Because some outlier detected. All right. So what we see here is actually the result of a analytics of a diagnostic analytics. From our benchmark analysis, we find out, okay, there's some problem in our company's performance. And then why does that happen? Okay, maybe we will go back, okay, and check what had happened in the past. Okay, what from the data that we collect, do some analysis, maybe schedule plot diagram, or maybe some correlation analysis. All right, correlate. Yeah. Okay. Mostly it's the schedule plot diagram. You see, is there any diagram that deviate from the normal performance? All right, and it's deviate. What caused it? Is there any other graph that we can show to prove, okay, to support or to explain that underperformance situation? Or maybe in our case, maybe the machine that we install, okay, in our plant, the machine keep on having abnormal. All right, yeah, because of anomaly event. All right, and then we move on to the example from the predictive analytics. For example, here is the maintenance, right? Predictive maintenance planning. Okay, we will use predictive analytics in order to, for example, answer a question like what might happen in the future. All right, this is the same thing, this diagram, this picture. Here we have a health status monitoring. We are monitoring the performance of our, for example, our machines or our equipment. We are monitoring it, and when we see some spike, either some spike or some sharp drop or whatsoever, any alert or any alarming message that we can see from our health status monitoring screen, when we see something abnormal happened, all right, our predictive model is able to tell us, okay, we should do what. For example, it says what? Failure predicted in 14 days. This is our health status monitoring. It simply being drawn based on, for example, based on our daily operations and based on our descriptive analytics, right? But based on what we see, because we have a predictive model, in which this predictive model is developed or trained based on our previous historical data. All right, based on what we happen now and what is happening now, we become an input to our predictive model. And the predictive model, which is built based on the past historical data, is able to predict based on this new input, okay, failure is expected to happen within how many days, right? That would be our predictive analytics. It telling us, it predict it will happen in 40 days. Okay. Obvious failure or machine failure or equipment failure will happen within how many days? 14 days. And therefore, we can carry out some proactive maintenance planning. And this proactive planning, to some degree, okay, you can consider is based on our prescriptive analytics. And then now we are going to look at another example of prescriptive analytics. Here you can see that prescriptive analytics is usually applied in system resilience, system reliability, and optimization. And assume that we would expect our system reliability to be to have availability at 99.99%. All right. If our system is available 99.99%, then our system is reliable. In order to ensure that our system is reliable, all right, the mean time between failures, mean time to repair should not be high, right? It should be what? Low. Correct. So the prescriptive will tell us, in order to achieve 99.99% availability, our mean time between failure and mean time to respond must be very short, right? Tell us what to do, but how to do it could be, yeah, it will be more further planning, as what we see in here. Okay, so-called proactive maintenance planning or proactive system reliability planning and so on. Okay,